Hello everyone, welcome back to my channel, Prince Automation Destination. So in our last lecture of collection series, we discussed about list interface and array list as the implementation of list interface we demonstrated in the last lecture. In case you are not already aware on the array list, I'll request you to please check out my that video, which I'll be sharing in the I icon as well. Okay. So we discussed like array list is implemented on the dynamic array data structure, right? So today we are going to cover linked list, which is another way of implementing the list interface, that is linked list. So in linked list, the underlying data structure is doubly linked list. So we will try to understand doubly linked list at high level as well. Okay. So before we move on, let us understand the list hierarchy in the collection framework, which we have already covered as well in the last lecture. But let us quickly recap it, right? So we have iterable, which is the root node in the Java collection framework. Then we have a collection interface, which is extending this iterable interface. Then we have a list, which is the topic that we are covering right now, interface, which is further extending collection. Then we have like classes implementing this list, array list as well as linked list. Uh, okay, so array list is already covered as you know, and linked list we are going to cover today. Now let us try to understand linked list as well. So now you notice that we have iterable, which is the root node. Then we have collection. We have then list, which is extending collection. Similarly, we have queue as well, which would be having functionality related to queue, which follows the FIFO data structure, first in, first out, while DQ have both the ways, meaning it does not only follow first in, first out, but it works in the reverse order as well, right? Now coming to the linked list. So linked list is actually following the multiple inheritance concept of Java, due to which it is implementing list as well as DQ interfaces of the collection framework. Okay, so as to utilize the functionality of both list as well as DQ. Okay, because of this, when we will be creating the object of linked list, so we can assign it to any parent, because DQ is also its parent and list is also its parent, right? So that is what we are going to cover as well, right? Then we are going to our few more operations as well. Before that, let us try to understand how array list look like and how linked list look like, right? So when we create an array list and when we add the elements, so what happens is, as soon as the array list is created, a contiguous memory location is assigned, right? So for example, by default, let us say a size 10 is assigned. I believe this is the default value, default capacity is assigned. So let us say we are adding 10 members, so they would be at the contiguous location, right? So they would be, for example, this is having 20 address, this would be having 21 address, 22, 23, 24, right? And corresponding to that, index would be assigned. So this will become 0th index, it would be first index, second index, third and fourth, right? So the values are stored in the contiguous location. Contiguous location means the address would be continuous, right? We discussed this would be 20, this would be 21, right? Now in linked list, how it works. So in linked list, as we have mentioned, that it is based out of doubly linked list. So doubly linked list data structure. So how doubly linked list data structure work? So first of all, let us try to understand the main building block, which is a node, right? This is a you can consider this is one node, right, which has three partitions: first partition, second and third, right? And when we create a linked list, the first node when we'll be adding, that will become a head, right? That would be the first node, right? Now this as it has three partition, first partition, second and third, right? So first partition stores the address of the previous node, but as this is the first node in the linked list, so it won't be pointing to any other node, so it is having address null, right? Now talks about the second partition, so it stores the actual value, whatever the value we want to store, it would be adding it, right? Next, this particular thing, it would be storing the reference of or storing the address of next element, right? Similarly, this particular node will also be storing the reference of previous node, so that they maintain or they refer to the addresses of each other. So in case of ArrayList, they were contiguous addresses, so it was easy for them to track. They don't need linking, while in this case we need linking. That's why they are storing the extra memory. They are having extra memory, and which is used to point to the next and the previous memory location of the nodes, right? And in case of linked list, this particular thing is the tail, right? So we travel from head to tail, right? But as this is the doubly linked list, so we can travel from the tail and tail to head as well, right? And as this is doubly linked list, that's why it is storing, this particular node is storing the address of this one, and this particular one is storing the address of previous one as well, right? Because it is storing the address of next one as well as previous one. That's why it is doubly linked list. While in case of single linked list, we won't be having this particular arrow, meaning it would be, the node would be storing the references of the next elements as well. But as linked list is using the doubly linked list data structure, so this is how it looks like, right? So we will be discussing about add, how to add value and how it differs. Then we will be discussing about removal as well, right? Now let us try to understand from the demonstration point of view, right? So as we cannot create the object of list, so what we'll be doing, we will be creating the object of linked list, right? So linked list, right? How to create the object of linked list, new linked list, right? As I mentioned that it is like child of both. So what we can do, we can, let us say we create the list of like linked list of string, because let us say we want to store only the list of elements, right? Now uh, what I can do, I can store it in either into the list, right? So I can give it name list, right? Similarly, what I can do, I can do like this as well. I can convert it into dq, right? But I'll give it name list one. So you see that the object of it, I can assign it to the list as well as dq. Why? Because this linked list is implementing list interface as well as dq interfaces. Let us try to understand from here, right? So I went inside the linked list. If you notice, it is implementing list as well as dq, right? That's why it is able to, we can assign the object of list, linked list I mean, to the list as well as dq. Let us go inside. So dq has its own methods, add first, add last, right? Similarly, list would be having its own method, right? So let us say size is empty, contains, iterator to array, right? So these are the different methods of list, right? So now what we will do, we have initialized the linked list. Now the point is to add it, right? So by default, when we will, for example, create the values, let us add the one value, and I will try to print it first, right? List, and I'm going to run it. Now you see that it has added Amit. By default, if I'll do list.add and prints, what it will do, it will add this particular element at the end of the node, meaning it would be adding here at the end, right? So let us try to understand the same. If I'll run this, what will happen? So you see it added Amit comma prince. Now the next thing is, so how to, so we have method of list dot add first as well, but that won't be visible to us. Why? Because even though we created object of linked list, but we are assigning it to the list parent, right? And list does not have this method, right? Add first, because add first is the method of dq. So what we can do, so there are two ways. One way is either I can convert this into linked list directly, right? Because we are creating object of list and we are assigning it to the linked list reference variable as well. Now by default, if I'll, for example, try to add uh, list dot add, and I'm adding last, 1. So what will happen? What will happen? It will add it to the last by default, right? So you see it added at the last. And then there is a method add last as well. Now I'm going to add last too, right? So what I want to show you, I'll just tell you, right? So you see, you will see that Amit prints last two, right? Now we added last two as well, right? So this is how it added the value at the last, but we removed that particular value as well. Just a moment, list dot last one. I didn't want to remove that. So list dot add one, I'm just going to reverse some operation, right? So what I want to show you that this list dot add will add the value at last, and this add last will also add the value at last. Okay, so we will try to understand that, right? So we'll see that Amit prints last one, last two. Why? How it is happening? So if I go inside this add, it is calling the link last method, right? Which is to link the node at the last, right? Similarly, if I go inside at last, it is also calling the link last, right? So link this add and at last are the same. Now, what if I want to add the value at starting? So for that purpose, what I'll be doing first, now, when I'll be executing this, what will happen? This particular value will be added at the first, right? First, Amit prints last one, last two. But if I want to add it somewhere um on the, like for example, this is 0th index, this is first and second, right? So for example, if I want to add and on first index, let me give it name first index, right? What will happen in that case, right? So you see that on the first index, this value got added, right? Now what if, now let us try to understand what actually happens in case of this, in this case, I mean. So when we are adding a value on the first index, this is 0 first, right? What will happen in that case? That first of all, the linking will be like disconnected. So for example, this one will be connected. So whatever, for example, object 2 was referring to object 3, this particular block was referring to the address of this object 3, and in return object 3 was referring to the address of object 2. Now what will happen, as soon as we will add it, it will simply disconnect or remove these references, meaning it will remove the address of this node, and it will start, it will add the address of, it will store the address of this particular node now, right? Similarly, this particular node in return will be storing the address of this. Likewise, same thing will happen here as well, right? Now the next thing is, so for example, let's say you I want to remove it, right? So how to remove it? So by default it will be removing it from the last, I believe. And what if I want to remove from the first index, right? So now let us see. So first index thing should be removed. You see, first prints last one, last two. So whatever the value we added, that got removed. Now let us try to understand what happens in case of remove, right? So suppose we tried removing from the first index. This is 0, this is first, and this is second, right? So what will happen in this case? So what will happen, first of all, this particular node previously was storing address of this one, and then this particular thing was storing the address of this one. What will happen? It will erase the address of this, and it will now store the address of the next node, right? And in return, this will also store the address of this one, right? So this is how it takes place, right? Right now, as we have understood like how to add the values into the list and how to remove the value into the list, now it's time to understand how to iterate it, right? So how to iterate it, for that purpose what we will do, so like as discussed last time, we have multiple ways. Let us discuss the first way. List dot iterator, and what will happen in this case, iterator of string, because we have strings, so iterator list dot iterator, right? Now while iterator dot has next, which will check whether it has values or not. This one, what it will do, it will print the values. Iterator dot next, right? Now we will try to print it, right? So it will print the values one by one now, right? So these are used, for example, when we want to use it, right? Now first Amit prints last one, last two, right? Got it? So as I mentioned that it is using DQ as well. So in DQ, we have descending iterator as well. So let us try to understand descending of iterator as well. Descending iterator, right? And iterator of string and iterator one, right? Right. Now when I will try to print this, iterator one dot has next s out dot iterator one dot next. So we'll see what is the difference. I believe it should print in the reverse order. So we see that it has printed the values in the reverse order. So in case we want to iterate in the reverse direction, so we can use this one as well, right? Now the next thing is how to iterate it using for loop. So it would be similar to that only, right? So for int I equal to 0, I less than list dot size I plus plus, right? This is one way. S out list dot get of I, right? And it should, I believe, print the values, right? So it will print the values. Now the next thing is how to iterate it using the enhanced for loop, right? So similar to that, as this is list which is containing string of values. So string, this is name, because this is a list of names. So like this, now what I can do, name, so it will print the values of name step by step. So you see that we're able to like print the values, right? So we discussed about like how we can initialize the linked list and how it is different, how we can add the values at first, how we can add the values at last, how we can add the values on a certain index, how we can remove the values from the certain index, and we discussed about how it internally happens as well, right? Now let us try to understand the differences between the array list and linked list, which is the most widely asked question in the interviews. So as we discussed that ArrayList implements the dynamic array, right? And linked list implements the doubly linked list, right? And in case of manipulation, in case of ArrayList, I mean manipulation is time consuming, because suppose if I want to add a value onto a particular index, what would be happening? So suppose I have 100 size list. What would be what would happen if, for example, I want to add it onto the 50th index? So it would be shifting all the bits by one step, meaning the shifting of like elements will take place and it will be assigned to the new memory. So it is time consuming. While in case of linked list, it is efficient because there is no bits shifting, right? Because we discussed, it will simply disconnect the link or remove the link and it will start pointing to the new node, right? Even though it would be traversing till that particular node through the indexes. So for example, it will go up till 50 and then it will like remove that particular node, and or for example if we want to add, what it will do, it will point to that node and that node will in turn start pointing to the next node, right? So there won't be any bit shifting. That's why manipulation is easy and efficient, I can say. So insertion is slow here, as I discussed. Like if we want to add some value onto the index, so it will lead to have bits shifting. That's why insertion is slow. While in this case, insertion is fast, right? Because as I discussed, that's just it is just removing the addresses of previous and last memory. Deletion is inefficient again, because if you will delete again, it will lead to have bits shifting. So for example, if I want to delete some value from the middle, then what will happen, it will again shift the like the values, the previous values to the like just one step back, I mean, right? Deletion here is efficient, as we discussed. Like it will simply disconnect the links or remove the addresses of that particular node, and it will start pointing to the previous node, right? And this array list, as we discussed, that it implements list only, so we can only utilize the like methods of list, right? While it implement list as well as dequeue, so it uses methods of list as well as dequeue, which we discussed, right? So we can assign the object of um, linked list to the list as well as dequeue, because both are the parent, which we discussed, right? Then where can we use array list, right? So it is used where we want to access and store the data. So as where there is a need to just store the values and we want to get the values. So for example, if I want to get the value for particular index, so what will happen for that, corresponding to that particular address, we will get the address, right, of that memory address, right? And we will be able to get the values, right? So random access is easy here, and if we want to get the values, then array list is the best suitable, right? But what if we want to add, there is a need of adding and removing the elements in between, then this linked list is the beneficial. And in case of array list, less memory is used, because we would be having only one memory address where we store the values. But in case of linked list, as we discussed, that we have three partitions, so that will lead to have more memory, because they would be storing the values address of previous as well as next node, right? Now the next question is, which one is useful for the test automation? Okay, so there is a spelling mistake, sorry for that. So which one is useful for the test automation? So as per my experience, we usually store the values and we access it. Sometimes we get it through the indexes by running the for loop. Sometimes we use the enhanced for loop, right? So usually we store the values and like retrieve the values. So for test automation, array list is a suitable. But what if there is a need to modify the list on the fly? Then I'll recommend to use the linked list. So this is what I wanted to cover as part of current video. Thank you for watching. I would request you to please like, share and subscribe. Thank you.